Okay, so there's a story that goes with this. So I'm Mike Littman. So this is from Kutztown, and it was there was a fellow. One of the vendors was from Portsmouth, New Hampshire. Some of you may know him. His first name was Roger. I've forgotten his last name, but he brings a lot of early instruments. This is a generator. You can see the crank on it. I took a look at the bottom of it and then Googled the name that was on it, signed. It's signed Charles L. Clark from 1899. So I became interested in this when I saw who Charles L. Clark was. So it's Charles Lorenzo Clark. So he was Thomas Edison's chief engineer and was responsible for the jumbo dynamos in Pearl Street Power Plant. And in 1890, he left Edison's employ in 1886 and part of the Edison company went up to Schenectady, New York, and that became General Electric. And then he worked for General Electric for most of his career. And then he had a number of patents. And so I got very interested in this particular device. It's a dynamo. So it's generators come in different forms. A DC generator would have a permanent magnet and a spinning armature. And it becomes a dynamo when the field is produced by an electromagnet. So this has two sets of windings. It's got a winding for the field. So there's a set of coils down below here that you would energize to provide the magnetic field for your generator, and then it's got a windings on the armature. Now, dynamos are, of course, Edison used a lot of dynamos for his DC power plant. The Edison ones were interesting because they were self-excited. So you would take you would take a pick off from the commutator, and you would feed that into the coils and for the field coils, and it would self-excite. So all you have to do is spin it and generate a voltage. Now this one's a little different. So those self-excited dynamos, if the armature here is a 12-pole armature, and you used to have multiple contacts on the commutator, and you just feed in one coil back into itself. This one has a commutator with only 4 contacts. So even though there are 12 poles in the armature, there are only 4 contacts. I wasn't sure what that was all about. But then it's also got another feature that's sort of interesting, is it has 4 slip rings. So you don't usually see slip rings in a dynamo. So the slip rings, so remember I said that there are 4 contacts on the commutator. So each one of the slip rings goes to one of the contacts. And it appears, powered this thing up, and it appears that multiple windings are connected to the individual. So let's see, 3 of them are connected to one, so 3 times 4 is 12. So that's so 3 coils for each leaf. So as near as I can tell, and I'm still trying to figure this one out, I think it might have been a demonstrator that allowed you to either generate DC or AC from the generator. So if you use the slip rings, then you have the classic AC that you can generate because you're attached to a set of coils. Or you could use the commutator and generate DC. I've also taken some of the signal from the commutator and fed it back into the coils, and it will self-excite. So, but as I said, I'm still trying to figure this one out. I was looking for a patent on it. I was unsuccessful as yet. But in the process of digging through this, which is part of the fun part, is trying to get something old and you try to figure out what it's all about. I found out that Bowdoin College has Charles Lorenzo Clark's personal papers. So when he passed away, his family, whatever, they donated it to Bowdoin College, which is up in Maine. And I have a relative up in Maine. I'm thinking of going up there this summer and digging through the papers and see if I can find anything in greater detail about this particular unit.
How much voltage does it generate?
So so if I separately energize the coil with a 6-volt battery, okay, then I can generate for a reasonable speed, I can generate 12 volts easily. Okay, but on a self-excited, it only generates about 2 volts. Now, what I also have from one of these Edison fans. the fans that were made in orange. And one of the things, one of my plans this summer is to see if I can use the self-excited portion of it. That runs on low voltage, because that would run from one of these alkaline cells. I thought it would be really cool if I could get this dynamo to drive the Edison fan. And I'll let you know maybe at the next one of these show and tells.
Wow.
But this was a demonstrator.
I think it's a demonstrator. So, by the way, if anybody has any other information or ideas about it, I'd love to hear it. There's a fellow in town who's also a collector, a friend of mine, Chip Kreider. I don't know if any of you know him. So Chip is a graduate of our electrical engineering department and lives in downtown Princeton, has a little electronics and vacuum shop. And he collects a lot of early instruments, especially generators and dynamos and lamps, and we sat around for about a half an hour trying to figure it out. And it was Chip's idea that it was probably a demonstrator, and I decided I think he's probably right. But there may have been something else.
Is there a gear train there, or is that
No gear train. It's all a direct drive.
Yeah.
So it's all direct drive. It was it wasn't all corroded and whatnot, so I cleaned it up very nicely, and it will generate AC. It does generate DC. It does all of that. As I said, the thing that's odd, and actually, Al, you're the one that I was really interested in your opinion on this. The thing that's odd is most of these, with these multi-pole armatures, is you expect a commutator that has lots of poles on it. This one only has the 4. So I thought that was a little strange. Also, you can advance the angle in terms of the pickoff, in terms of relative to the field, as to where you can usually adjust your brushes. This one, it's fixed and it's right at 90 degrees. So that was a little strange, but it definitely works as a generator, DC generator, and it works as an AC generator.
We have a member, Pete D'Angelo. You'll never see him coming down here, but he also has a passion for collecting early instruments and motors and generators. And I'll take some pictures and I'll show him. He may even have one.
Great.
See if I can get some info.
Okay, thank you. Okay, that's
Thank
it.
you.